All right, hello everyone. Welcome to our first video for this class. We are kicking off this semester with section P3, integer exponents and scientific notation. All right, so make sure you take notes, and if you need the closed captioning, just go ahead and click on the button down below that has the CC on it. All right, let's go ahead and get started here. Take notes. And as you are taking notes, feel free to message me any sort of questions that you have about the lecture. Okay, so we have P3 integer exponents and scientific notation. So the P chapter in this textbook is all prerequisites. These are the things that you should already know, but it doesn't hurt to review. So I've chosen sections P3 through P8 to quickly review. Okay, so exponential notation. This is helpful, especially if you haven't taken a math class in a very long time, or if you feel like you've forgotten a lot of the stuff, even if you've taken a class last semester. All right, so for example, you might have something like this, 5 to the third power. So this here is the exponent. And this here, this 5, we call this the base. Okay, and what this means, 5 to the 3, means 5 times 5 times 5. And 5 to the 3 equals 5 times 5 times 5, which is 125. Okay, so make sure you understand that it means 5 times 5 times 5, not 5 times 3. All right, so here are some examples. So you might have 2/3 to the fourth power. So again, that means 2/3 repeated multiplication. So we have this here, and this would equal 16. 2 times 2 is 4, times 2 is 8, times 2 is 16, over 81. 3 times 3 is 9, times 3 is 27, times 3 is 81. Okay. And then we have these two here. A lot of students, even in calculus, will mix up these two. So if you notice here, this one has these grouping symbols, and then this one over here does not. And that makes a big difference because when you take a look at this one over here, this, because we have the grouping symbols, is saying that the base is -2. So the -2 gets repeated. Whereas over here, this one doesn't have grouping symbols. Therefore, the base is not -2. It is only 2. And so only the 2 would get repeated. Okay, so up here, this one, the -2 is the base. So the -2 gets repeated. 1, 2, 3, 4, 5, 6. Whereas this one over here, the 2 is the base, not the -2. So the negative would be all by itself out here, and then it's just the 2 that gets repeated. 1, 2, 3, 4, 5, and 6. Okay, and this makes a big difference because over here, when you do -2 to the 6th power, we get 64. And over here, when you do 2 to the 6th power, you get 64, but then you have this negative on the outside. So this would be a negative result. Okay, so that is just something that you have to watch out for. If you have grouping symbols, it's this entire group that gets repeated. If you do not have grouping symbols, then only the 2 gets repeated. Okay. All right, so let's take a look at the laws of exponents. All right, so let's start with these first 3 basic laws. So when you're multiplying like bases, A and A match. So if you have like 2 cubed and 2 to the 5th, not 2 cubed and 3 to the 5th. Okay, so the bases match. And if that's the case, then we keep the base, we don't multiply them. And we add the exponents. Okay, so for example, if you have 2 cubed times 2 squared, then we don't do 2 times 2 is 4. We don't do that. Okay, this becomes 2 to the 3 plus 2, which is 2 to the 5th. Okay. The second one, if you have division of like bases, okay, then here you would simply uh, subtract the exponents. Okay, so that over here, if you have 2 to the 5th divided by 2 to the 3rd, then this would be 2 to the 5 minus 3, which is 2 squared. Okay. And then this third one, when you have like a power to a power, so maybe you have a to the m raised to the n, then you would multiply the exponents. So for example, you might have 2 cubed squared, and this would be 2 to the 3 times 2, which is 2 to the 6th. Okay. So those are their 3 most basic rules of exponents. When you have product, add the exponents. Quotient, you subtract them. Power to a power, you multiply. Okay. We also have the 0 exponent. And negative. Okay. So here, so let's suppose we have a base A, but it's not 0. Okay. And suppose A is a real number as opposed to an imaginary number. And let's, for simplicity's sake, let's make n is a positive integer. Then a to the 0 is 1. Okay. And if you have negative exponents, then we take the reciprocal. Okay. Okay. And then we have more laws of exponents. So number 4. So if you have a group like this here, then again, everything in there gets repeated. So everything in there is a base. And so everything in there gets this exponent. Okay. So for example, if you have 5x raised to the 3rd, then the 5 would get the exponent, and so would the x. Okay. And this, of course, it's just 125x cubed. Whether it's a product or if you have a quotient in there, the same idea still applies. Everything in there is the base, so everything in there will get the exponent. So a to the n and b to the n. Okay, so for example, if you have 5 over x to the third power, then the 5 is the base, and so is the x, and so we would get 125 over x cubed. Okay. And then with negative exponents, if you have something like this, a over b to the negative n, then what happens again? So when you have negative exponents, then you end up taking the reciprocal. And so here that would just switch this here, and that exponent now becomes positive. Okay. So for example, if you have 5 over x raised to the negative 3, then here that would take the reciprocal of that fraction, x over 5, and now the exponent becomes positive. Okay? And so then now we can say, oh, that's x to the third power and 5 to the third power, which is just x to the third over 125. Okay? And this last law of exponents, if you have a to the negative n, b to the negative m. Okay, so again, when you have negative exponents, you just take the reciprocal, and when you take the reciprocal of something like this, you can think of it as, oh, okay, so they just switch uh, positions. So if the a has a negative exponent, it's in the numerator, then the a now goes in the denominator. Okay. And if the b is in the denominator and it has a negative exponent, then now it moves to the numerator. Okay. So for example, if I have 5 to the negative 2, 2 to the negative 3, they both have negative exponents. And it's really only the ones that have negative exponents. If it had a positive exponent, then it doesn't move. Okay, so then the 2 would move up, and the 5 would move down below. And that would just be 8 over 25. Okay, so let's go ahead and have you try some of these just to make sure. So I'm going to go ahead and give you 3 problems here to try. X to the 4 times x to the 7th, y to the 4th, y to the negative 7, and this third one, c to the 9th power over c to the 5th power. And go ahead and hit the pause button and give these 3 a try, and then come back and see if you get the same answers that I have. Okay, so this first one here, we are going to add the exponents. So you should have gotten x to the 4 plus 7, which is x to the 11th. Okay. Over here, different ways to do number 2. Here, you're going to add the exponents. So it's going to be 4 plus negative 7. And that's going to be y to the negative 3. But we don't want to leave it with negative exponents. So let's go ahead and take the reciprocal of that. So it's 1 over y to the third. And then this one down below, we are going to subtract, and we get c to the 4th power. Okay. And go ahead and try this next set. Go ahead and try b to the 4th raised to the 5th, and 3x raised to the 3rd, and x over 2 raised to the fifth. Okay, hit that pause button and come right back. Okay, so here we're just going to go ahead and multiply these here. So that's just going to be 4 times 5. So that is b to the 20th. This one here, the 3 gets the exponent and the x gets the exponent. So that is 27x cubed. And here the x gets the fifth power and the 2 gets the fifth power. So that's going to be x to the fifth over 32. Okay, excellent. Again, if you have any questions, make sure you message me. All right, and let's go ahead and try this. This set, I'll just give you 2 here. Go ahead and try this one. 2a cubed, b squared, 3a, b to the fourth cubed. So give that one a try, and go ahead and give this one a try. Y squared x all over z raised to the fourth power. Okay, hit that pause button and come back to check your answers. Okay, so here, order of operations, we need to do exponents first, so we need to take care of this first. So I'm going to bring this over. And then here I get 3 cubed, a cubed, b 12, because we have to multiply the exponents. Okay, and if you don't see an exponent, and that has an exponent of 1, and so does the a. Okay. Okay, so here 3 to the third power is 27. 27 times 2 is 54. Okay, so that takes care of the 2 and the 3 cubed. And then I have a to the third power, a to the third power, a to the third power. That's multiplication. So I'm going to go ahead and add those exponents and get a to the sixth. And then over here, this is also multiplication. So I'm going to add the exponents and I'm going to get b14. Okay. All right, let's go ahead and take care of this one. So this first set, I'm going to get x cubed, y cubed. And then over here, I'm going to get, oops, that's not a 4. That is y to the 8th, x to the 4th, z to the 4th. Again, if you don't see an exponent, it's understood to be 1. So like right here, that's an exponent 1, that's an exponent 1. Okay. All right. And then I have x cubed times x4. So this is multiplication, x cubed times x4. So that becomes x7. And then over here, this is division. This is y8 divided by y3. So I'm going to subtract the exponents and get y to the fifth. And then z to the fourth will remain here. All right. And let's try some with negative exponents. Give these two a try. Try 6st to the negative 4 all over 2s negative 2t squared. Okay, so you're going to try that one. And this one. Y over 3z cubed all raised to the negative 2 power. Okay? All right, so different ways to do these. Hit the pause button, give it a try, and then come back. Okay, so different ways to do these problems, different ways to start. Some people like to just work with the exponents that they have. I like to I like to turn my negative exponents into positive exponents first. I like to move everything around. You don't have to do it that way. It's up to you. Okay. 6 divided by 2 right here is 3. So I'll take care of that. This s can stay, but this one on the bottom, since that one has a negative exponent, I'm going to move that up. And since this has a negative exponent, I'm going to move that down. And this one will stay. And then I can use my laws. Multiplying, I add the exponents, so that will be s cubed. Multiplying here, I add the exponents, and that's t to the 6th. Okay. All right. And let's go ahead and do this one. Here, everything gets a negative exponent, so everything will get flipped. And now the exponent will become positive. Again, different ways to attempt this. So long as you get the same answer at the end, that's fine. Okay, 3 squared is 9. Z to the 3 times 2 is 6. And y squared. Okay. All right, fantastic. Okay, so I'm going to go ahead and end part 1 there. Part 2 will be about scientific notation, very short video. All right, again, if you have any questions, make sure you email me, make sure you text me, and make sure you're taking notes and keeping up with the assignments.